remember we have relative humidity on the top, temperature on the left, okay? So then that makes up our EMC calculation, right? Relative humidity and outside air temperature is EMC, okay? So this is for yellow corn. So with the controller, this top yellow line, all right, we're going to set a minimum air temp. So we're not going to let our fans run below 30 degrees, okay? That's going to set that yellow line. We're also going to set a maximum air temp in natural air drying mode. Okay, so we're never going to let our fans run above 90 degrees. Don't want that hot air in there, but we still want to give it a little flexibility because we need runtime. We're trying to dry, okay? We've got a shelf life problem we're trying to deal with. Okay, so we're going to set that at 90 degrees. So with our suggested settings that are inside the door of the controller, we're going to say our current moisture, 18%. Okay, so this 18% level is good for up to 22% moisture yellow corn. Okay, so even if I had 21, 20, I'm still going to put 18 because you don't get a lot of drying done in this area up here. Okay, so your current moisture sets the top end of the window right here, 18 to 18. All right, we're looking for 15% yellow corn, so we draw another line there. That's what we call our target moisture. Current's what we have, target is what we want. Okay, we have our plus or minus moisture here, soft window around the controller. Then we have our bottom end of the window, which is set by our target moisture minus our EMC limit. And that's a setting in the controller as well, EMC limit. You guys have probably seen that. So, if you remember anything today, remember that the EMC limit, so target minus EMC limit, is an aggressiveness setting in drying mode. Okay, so the higher your EMC limit, the lower this window is going to be. So this is, in this case, our target's 15, we're going from 12 to 12, our EMC limit's 3. All right, if we had a 5 EMC limit, we'd be down in this 10 range. 15 minus 5 is 10. Okay, so that's an aggressiveness setting for this side of the window, EMC limit. Okay?
The higher the moisture that you have in the bin, the wider the window you want, more fan run time. The wider we can run because we can use some of that wetter air because we're still drying below that 20% or 22 or whatever you have in the bin. So we can widen out that window. But as that moisture drops down, you start putting 17 in the bin. If we ran 5 points below your target or 7, then the potential to overdry because you're actually running more below your target than above, then that's where you can have the potential shrinkage.
So, when we're going to be running with a moisture window like this, is anywhere within these lines in natural air drying mode with the suggested settings on the inside of the door. Okay, anytime the EMC is within these boundaries, that's where we're going to run. So we can adjust this. We can pull the current moisture down as we go. We can bring the bottom end of the window up to tighten that window. Okay? So these are suggested settings on the inside of the controller. These are just what we went through on that window. See, 18% current, 15.5 target. These are the things that need to change in storage mode for your maximum air temp and your target temperature. Okay, so we want to maintain a temperature inside the bin that's easily sustainable with the outside air conditions. So we make these seasonal storage mode changes. We'll show how those numbers factor in. So what we're doing with those suggested settings is we're creating our operating window, our moisture window, a top and a bottom cutting off the extreme. So we have EMC floating in and out. Anytime that EMC is within those two the top and the bottom ranges, that's when we're going to have runtime. Let's say we did start out with these suggested settings. We got a current moisture 18, target moisture 15, EMC limit of 5, and a plus or minus of 0.5. Okay? Standard door settings, right inside the door of the controller. What this does is this creates your moisture window. The top is set by your current moisture, 18. The bottom is set by your target moisture, minus your EMC limit. In this case, 10%, 15 minus 5. Okay, so let's say we pull a sample and we're 17. We change our current moisture to 17, which adjusts the top end of the window down. We also want to change our EMC limit. Brings the bottom end of the window up. So as we're cutting the extremes off, we're cutting it more and more and more and more, going down into our target moisture. So as we get down to 16, let's say we have current moisture, we set that to 16. Our bottom, we also want to adjust that with our EMC limit. We lower our EMC limit, 15 minus 2 is 13. So we're bringing it down from the top by changing our current moisture, bringing the bottom end of the window up by decreasing our EMC limit to end up right where we want to be. Take home to this is looking for that direction during drying mode. Okay? The two basic changes you need to make to adjust that window. Okay, we're narrowing in on where we want to be, because once we get to be where we want, we're going into storage mode. Telling the controller at this point, we have what we want. In this case, we have 15.5% yellow corn. We want to keep 15.5% yellow corn. So in that case, both current and target have to be the same. Okay? We then adjust our plus or minus moisture from that was 0.5 in natural air drying mode, goes to 2.0 in storage. Target moisture plus or minus moisture makes up our storage mode moisture window. We're watching our temp cable right here. Notice that we set, for a good fall setting for storage, we set it at 45 degrees with a plus or minus of 5 degrees. So we want to keep the average of all of our sensors that are X between 40 and 50. 45 plus or minus 5. Anytime we get outside of that range, above 50, below 40, that's when we're going to run. Okay, but we're going to be under direction of our minimum maximum air temp, then we're going to go to our moisture window. Am I between these two numbers? Yes, going to run. Basically what we're saying is we don't want to have quality change, we want to maintain temperature. Okay, so another way to explain storage, same information. Current moisture 15, target moisture 15, plus or minus 2. So what that does is that makes up your storage mode moisture window, 17 and 13. We're also under direction of our minimum maximum air temps. For fall storage, we're 30 and 60. And then, so it'll only run when your air temp is between 30 and 60 degrees. And then you're under direction of your average of all your sensors that are X, or your target temperature, plus or minus 5 degrees. So when your sensors are between 40 and 50, you're not going to get any runtime. With low temp burners, see, so this is your regular fan moisture window. When you get to this point, you're on the outside of being able to utilize your fan. This is when your low temp burners kick on. So EMC's out here, you're running your fans, it gets too wet, low temp burners kick on. Allows you to run a lot longer, have longer operating hours during the wet fall. Okay, gives you that temperature rise, burn off that humidity. When that EMC comes back down into your fan runtime, your burners kick off, fans stay on until you run on the outside edge, and then it kicks your fans off too. Low temp burners give you that optional runtime in order to push through dry a little bit more than what you usually have with just a fan alone. So when we're looking at changing moisture settings, and we'll use a soybean example really quick. Assume that you have 10% moisture soybeans coming in. So in moisturizing mode, after, we just went through the natural air drying window. Moisturizing mode is an inverted drying window. Okay? So in this case, our current moisture, we want to set that at 13 for our soybeans. We're not saying we have 10%, this is what we want, like we would in natural air drying mode. We're creating basically a favorable window to run the controller. When we want to run our fans, we want to have this window set up. Okay? So we're saying we have 13% soybeans. This sets our bottom end at 13%. So we're never going to run any drier than 13. If we set this at 10, we have the potential to put 10% moisture air in. 10, 11, 12, not 13 what we want. So we set our bottom at 13%. So what this does, we're never going to be any drier than 13. We also have to limit the top end as well. Because remember, too much humidity, what does it do? Moldy grain basically shrouds the grain right around the floor in the fan, can't push any fronts through. We need to limit that top. But inverted drying window, our target moisture now is added, or EMC limit is added to our target moisture to get the top end of the window. So we're limiting that top as well, okay? So not too moist, but definitely not too dry. The important thing to remember about moisturizing mode, you want to baseline your static pressure. Keep track of it. So if it ticks up a point, you can adjust your window, pull some grain out.
Dry load store, one